Alright? So,
Hold on, give me a second, I got to try it. I gotta do a taste test. Not mine, I do cameraman.
waiting on you, Juwan.
You ain't hear me say not a word.
Juwan, do you understand how long I sat here and looked at you
How
and
you
watched
zoom?
you?
My nigga, how you zoom out?
I'm never sharing with you.
So, first things first, a lot of us made a great prediction that whatever this function is, it's going to have how many roots? 2.
3.
Bro, 3.
See, so Bakari, this is why we need to talk to people and look around the room. We see people because most people noted that they think it's going to be 3 roots because there were how many x-intercepts from the factor? There were 3, right?
I see it now.
Okay, so there's 3 x-intercepts. Remember, Brady, why are you using scissors and scraping them against your skin? Come on, let's be smart. So, we noted that there's going to be these 3 x-intercepts, right? And so, Cameron, were you the one who wrote, I think it'll be cubic, or be a cubic? Is that what you're starting to write?
He's right,
Yes?
right there.
Okay, what do y'all think? What, oh, that was Deanna who said that? Okay, but he wrote it, yeah. What do we think? Should it be a cubic?
Yes.
Yeah. Why? So there's 3 roots,
You can tell I sold.
so x to the third, right? The degree should be 3. There's going to be more to it than just x cubed, Maddie. Okay? Listen, back up. I'm tired of people being in the wrong, and then I'm only seeing them, and then they get upset. Like, but, Maddie. One, I didn't see J Mike do it, but I've gotten on to J Mike plenty. Like, we always want to get upset when we're the ones called out. But if we weren't screwing around in the first place, J Mike, and getting other people distracted, or whatever, right? Like, if we were all on task, 1, no one would get in trouble. 2, we would learn more. 3, please don't act like I'm cussing you out, yelling at you, writing you up. I'm redirecting you because I want you to learn. Okay, so 3 roots, so x cubed. Now, what I want to talk about is some of the predictions. So some people were looking here, thinking maybe it looks like this function, but there's another group who, let's see what the groups.
Hey, Taj.
I thought there was.
Hey, Albert.
Oh, so I get her.
What?
Alright, gotta zoom out right quick. Day and night. That's okay. Why did this shit not tweak it?
I did 2 times. Negative 6 times.
So, I want y'all to look at this prediction. So, Maddie, if you could hit the lights for me. Notice.
Sure.
Maddie, or Bakari. When I ask Maddie, let Maddie do it.
Yes, sir.
Okay. So notice this prediction is actually very different than what some of the other groups were predicting. Okay? Hey, it's ours.
No, we didn't. We wrote on the iPad again. Then.
You're good? You good? So I can teach? So we can focus and learn something?
Ooh,
Okay.
clock that.
So, what we are looking at here is a little bit different. Most groups were thinking it was going to do this. Same exact x-intercept, but notice it's a different direction. And so, this is Kamaya, Taj, and J Mike. So why did y'all start with positive values here?
Because of the fact.
So remember, we want to look at the factors. Notice how they marked the x-intercepts? Yeah. What type of value does this factor have? What type of value does this factor have down here? And this is?
She was my fucking.
And what do we get when we take a positive times a negative times a negative?
Negative?
Well, what's a positive times a negative?
Negative? Positive, negative, negative.
I'm just going to make up an example. What's positive 2 times negative 2? Negative 4. And what's negative 4 times negative 2?
Negative 6. Positive 6. Positive 8.
So, it's going to be a positive, right? Remember, if you have 2 negatives, it makes a positive. So notice, Does their prediction of being positive right here make sense?
Yes.
Makes sense to me. When I look in between these zeros, this green function has what type of values?
Positive.
Y values?
Positive
Positive
game.
values.
Thank you. What type of values does this function have?
Positive.
Positive.
And what about down here?
Negative.
And what do I get when I take a positive and multiply it by a
Negative.
positive times a negative?
Pretty sure you get a positive.
Negative.
Pretty sure you get a negative.
How many negatives are there?
One.
One.
So it's going to be
Negative.
negative. And so notice, do they have negative values here?
Yeah.
Yeah? Now I look in between these zeros. This function has,
Positive.
this one has,
Negative.
and what do I get when I take a positive and I multiply it by a negative and I multiply it by a negative?
Positive.
So all these values are positive, and they turn around and come back to the zero here. Now, I need y'all to be careful, because the most common mistake students make right here is this. They take a positive and they multiply it by a negative. And they end up actually getting the right answer here. But how many factors do we have?
3.
We actually have 3 factors. You always need however many factors there are. Remember, this green function is also going to be what?
Positive.
And so it goes down into the negatives. That's a very strong prediction based quite literally on what we had already done. A lot of us did a great job of noting, hey, 3x-intercepts is going to have 3 zeros, it's going to be cubic. But Taj and his group went beyond that, and they looked at the fact that we know we're multiplying these outputs, right? Determine if the factor's values are positive or negative. Multiply the positives or negatives to determine if the outputs of the polynomial are positive or negative. That's a good prediction. Not saying if it's right or wrong, but I am pointing out that that's what they said. Because what I need us to think about is here. So, solid prediction. As an ending point, right here, what type of function is created
Quadratic.
when we have 3 linear factors?
Quadratic. No, it's concubine.
It's
What? It's
cubic.
Cubic function.
Okay.
That's what I meant. Cubic function.
Hey guys, he's still talking.
Let's see if I was it.
Thanks, Bruce.
So, notice Vicari's initial assessment was that this would be quadratic. Could this be quadratic?
Yeah. But it's cubic, right?
Well, so can it be quadratic?
No.
No. If
it's cubic,
it can't be
it can't
2
be-
functions.
One,
It gotta be 1 function.
is this a parabola?
No.
That's definitely not a parabola. 2, how many roots do we have?
3.
So it's cubic.
So, it would be, so when we have 3 linear factors. Holy crap, you remember that time when I waited 45 seconds for the class to stop talking and then I started teaching it and we just started talking again? Yeah, that's real irritating. When we have 3 linear factors, what type of function is it creating?
Cubic.
You've already said it multiple times.
Cubic.
And cubic.
You gotta put that in the notes now, I ain't gonna lie.
You don't have to, because we'll review this tomorrow. But
Okay.
here's something I want you to notice, and I want you to think about. A linear function has how many zeros? 1. This linear function has how many zeros? 1. Just 1. When I multiply by another linear, it creates another 0, doesn't it? And then when I multiply by another linear, it creates another 0. What we want to recognize is when you multiply by more factors, it creates more zeros.
Wow.
So when we dilate by polynomials, we're creating new zeros. Every time you have a new factor, it creates more zeros.
Person, I'm going to camera now.
That's what we're going to pick up tomorrow.
All right. Addison. Addison.
Trying to have a whole class conversation at this point. So, guys, the steps are still up here. You wrote these steps down. I don't usually give you straight up, this is the thing to do. I make you think about it and figure it out, and then we talk about it, and I do eventually give you steps, but I gave you these steps pretty straightforward right away. Most of us did not take the time to do what first? Identify the zeros. That's it. Take the time to identify your zeros. We know the zeros are going to be the same as the factors. There they are for this group. Now, when I'm looking around the room, I need to remind you that something I've done every time that I highly recommend you do is mark those zeros. This is what we saw in the Desmos activity. What do I mark those zeros with? Or at least a vertical line that goes through there. I guess I need to explain why a little bit more or say it again, but listen. When I mark off those x-intercepts, those zeros, I now know that I have 3 regions I'm going to look at. I'm going to look at this side, everything to the left there. I'm going to look in between, and I'm going to look to the right. That's why I mark those x-intercepts. Because I want you to notice here, when I look here, what type of values does this factor have?
Negative.
Negative. Okay? So I got negative values. What type of values does this factor have? And what do I get when I multiply a negative times a negative? So everything to the left over here is going to be positive. That's it.
Right.
That's all it is. When I look at this set of factors, what type of values do I have? Positive. Here are... And what do I get when I take a positive and I multiply it by a negative? Negative. All those are negative. And then a positive, where's the... Oh, please note, this line's going to continue. So what's a positive times a positive?
A positive.
Language, Taj, in my classroom. So, as I said at the beginning of this, and as I will repeat, focus on the outputs of those factors. Are the outputs of the factors positive or negative? Because what we are literally doing is multiplying those outputs. That's it. I'm using the outputs of my factors to figure out what this function would look like. That's it. Okay? Now, what I need you to do is one person per group is going to pull up this Desmos activity that's going to help us understand this a little bit better. So, ladies and gentlemen, one person per group. Does everybody, somebody in y'all's group have this being pulled up?
Yeah.
You sure? How about you go over to your group and make sure that someone has it pulled up?
I don't want to vote for either one of them. Why we gotta do both of
Can y'all please go to your groups and make sure that someone in your group has it? We have a new activity.
Hey, few dogs should
Huh? Hey, you know right here, guys.
What about this one?
Yeah, then what, Jerry, pulling up? Let's finish up these sets of notes from before lunch about if a polynomial has positive or negative. I should say values. Now remember, when I say values, what type of values am I referring to?
Zeros.
Not always zeros. The output. Brady, how you learning if you're talking that much?
I just said one word.
That wasn't one word.
I said it, and then you said
Before I called you out, maybe. But you forgot to try to have a whole conversation, bro. Fix it. So, if a polynomial has positive or negative values, outputs.
You said what happened?
What sketchy bullcrap are you trying to pull in my classroom?
Yeah, they bought first. What you said?
them.
I just what? No. What's going on?
So, what do we need to do first? I need
the
zeros. I want you to remember, it is around those zeros that things can change from being negative to being positive, right? Then we determine the positive or negative, well, let's say it this way. Determine if the factors values
You want to change that today?
are what?
It.
Positive or negative?
Term it. Term it factors. Term it.
Sorry, dog.
They're home.
Just kidding, so why you write this stuff in here?
What? Taj, J Mike, you got all this stuff written down?
Oh, no, sir. No, sir.
I got everything.
I was ready earlier, though.
So, once we determine if the factors' values are positive or negative, what do we do? Right? Remember, the whole thing is that we're multiplying the outputs, right? So I took these positives and I multiplied it by these negatives, right? So once we determine if the factors' values are positive or negative, multiply positives and negatives.
What's the problem?
They talk about the word. Don't even worry about this.
Come on, you're full of it. Multiply the positive and negative to determine if the outputs are what? Positive or negative. Guys, that's it. It's all about those zeros. It's about how the zeros change from being positive to being negative. So multiply those outputs to determine if the outputs are positive and negative. We're not graphing super accurate graphs. We're just sketching the positives and the negatives. And I'm not going to write this down on the board. This is something we should already know. How are we going to determine, so bottom left corner, so bottom left, it says the zeros of a polynomial based on the factors. How do we know what the zeros of the polynomial are based on the factors? Okay, so the x-intercepts of the what? So of the, but what are we going to call these lines?
Oh, wow.
Those are the factors, right? Remember those lines, because it's not always going to be linear. I'll say that. So remember earlier, Taj, when I showed up here how we started with a quadratic and then we multiply it by a linear? So it's not always going to be linear, but it is always going to be a factor. So, and I wouldn't just say the x-intercepts. Remember, the zeros of the factors are zeros of the polynomial. So that includes both imaginary and real zeros. So the zeros of the factors are also the zeros of the polynomial. The bottom left, guys, where it says the zeros of a polynomial. Bottom left, where it says zeros of the polynomial. The zeros of the factors are also the zeros of the polynomial.
Write that on
Oh my God.
Yes. All of that was in the right spot. Guys, what we just talked about a second ago went in the top right. We are now in the bottom left for identifying the zeros of a polynomial based on the factors.
My bad, OG.
The zeros of the factors are also what?
zeros of the polynomial.
Zeros of the polynomial. The dilated function.
The zeros of the factors are the zeros of the polynomial.
Yes. So the zeros of the factors. Tyler, did you get all that written down?
He doesn't even have a good one.
Who the one so funny? The zeros of the factor. What?
Like zeros of the polynomial.
Zeros of the factors are also zeros of the polynomial.
What do you say?
Kamaya, did you get all that down about the zeros?
Yeah.
Okay.
Yes.
So,
Wait, whoa. Wait. What, is that the first box still right there?
The dilating stuff, yeah.
That's the bottom one. Wait,
Bottom.
that's the second one.
That's dilating. That right there is triangle.
This is top right. We should have been had this written down.
I've been wrote
The
down.
bottom left about where, what does the bottom left title say?
There's a
The zeros of a polynomial. Based on factors. The zeros of the factors are the zeros of the polynomial. That's it.
This is a lot of words.
The zeros of the factors are the zeros of the polynomial.
How many words?
11 whole words.
That's a lot of words.
11. Okay. We are now on slide 14 of the Desmos activity. This is where we are ending with activity 1. This is where I got to in 4th block yesterday, so we got to pick it up.
I wasn't here.
Congratulations. So, I need us add our vertical surfaces. I will make this quick note. You don't have to pull this up on your laptop or on your iPad, because as long as you just have a quick sketch of these two lines, what I need you to do is make a prediction what the function resulting from the product of the two linear factors would look like. So we've got two linear factors. I need you to make a prediction what the dilated function will look like. Dewan, what did I just ask?
What was that?
What did I just ask?
You want me to see what the dilated function is?
About
That's what you said.
It's pretty darn close.
Yeah.
Okay. Well, let's actually engage in this.
All right, bro.
Tyler, I need you to rejoin your group.
Mr. Kenny said he wanted. I got a question,
Yes, ma'am.
but it's not about math, so don't do that. It came
So
from
then
my-
don't ask that question right now.
No, hey.
Let's get on to our vertical surfaces. Let's work on identifying what this dilated function would look like. Product of those two linears.
Oh my gosh.
Press it.
I only got one right now. And I got instruction, transforming.
The lid came out. I thought they saw me fall.
Okay. So, dilating a function by an expression. So what is happening when I take, so I'm going to start with this red function, and I dilate it by this blue function. What have we noticed so far is happening there?
Go down.
It's gonna get wide on the number. I mean on the x-axis.
Say it one more time.
It's gonna get wide on the x-axis, and the parabola gonna widen out with it, or it's gonna either go down.
Well, let me ask this question a
What was
different
the
way.
question? I couldn't hear. I'm sorry.
So we're looking at our Frere model, our check understanding set. Up here it says dilating a function by an expression. So right now, I have this red line, okay? F of x is there. I have nothing else, just f of x. And I'm going to take that line and I'm going to dilate it or multiply it by this purple line. What happens when I take a function and I dilate it by another function?
If you take a function dilated by
It's going to create a parabola. Now, is it always going to create a parabola? So, we're going to build on this, but I will say this. So, first off, when we say dilating, what do we really mean? Okay, so dilating a function means...
You want to write that?
No, I'm writing on the board for kicks and giggles.
That was some amazing sarcasm.
What page you writing on?
Constructing polynomial
But
functions.
where it talks about dilating a function by an expression. There's one right here. Now, what are we multiplying? When we dilate, what are we multiplying?
Dilate.
Don't forget, when we say dilating the function, we mean multiplying the outputs. That's the key, right? That's the foundational piece. But we want to be able to add on to this. So, Mel brought up this, that we've always created a parabola. What type of function have we been creating?
Quadratic.
Quadratic. But I do want to point this out. What type of function? Well, actually, let me do this real quickly. It's here, okay? I want y'all to look at this. In this case, hey guys, in this case, I'm starting with what type of function?
Concave.
It's a quadratic function. And what am I doing to the quadratic function? So that's f of x. Yeah, but what am I multiplying by?
X and 1.
X plus 1, but what type of function is that?
Factor.
What type of function is y equals x plus 1?
Linear.
Yes.
Oh, lit.
Just the x plus 1 would be what?
Linear.
Linear. Isn't that the same as y equals mx plus b?
Yes.
So that would be a linear function. So if I take a quadratic and I multiply it by a linear, do you think it's still going to be quadratic? Bakari, can you hit the lights for me?
No, that just looks a mess.
It doesn't look a mess. We may just not have studied it yet. But look at it. Does this look like a quadratic?
No.
At one point,
Well, right there, do, but now I don't.
it's just like a whole bunch of
It's not a whole bunch of random stuff, guys.
It looked like a heart.
It kind of looks like two, so Addison said it kind of looks like two parabolas, but I will point out how many functions are right here.
I see.
Only one.
How many functions?
Yeah, this blue one right here, how many functions is that?
Yeah, it's one, but it's three zeros.
So say it again, it's three what?
Zeros. Which means it's a cubic.
Oh yeah, so if it's 3 zeros, then what's the power?
Cubic.
What's the degree?
3.
Okay, so we're going to talk more about this soon, but Dewan is pointing out that, hey, we have 3 zeros here, right?
Yes.
And if we got 3 zeros, it's not quadratic, it's not x squared, it's x cubed.
Yeah.
Right? Remember we talked about that fundamental theorem of algebra. Whatever the degree is, that's what?
The what you call it? The amount of zeros.
How many zeros it has, right? How many roots it has.
Yeah.
Whatever the degree is, that's how many zeros it has. So if it has 3 zeros, it's got to be third degree. My point is, it's not always going to be a quadratic, right? So what is making a quadratic here? Why has this always been quadratic?
Because of concavity.
Because it's, say that again, Addison. Two linears, right?
Okay.
So ooh, I can't put blue and orange like that.
No, that's horrible.
I mean, you can still see it, don't matter.
No, it's about the colors. I can't.
Nobody like
As long as we can see it, don't
I
matter.
Nobody like
can't.
no arcs.
So multiplying
Roll tide.
two linears creates a what? A quadratic.
Yes.
We're going to go into more about why this is the case, but we want to notice, at least so far, so when we are multiplying, by the way, what's another word for multiplying? Multiplying is operation. Dilating, right?
Jeez.
Graphically, what we're doing is we're dilating. We're starting with one line, we're dilating it by another, so we end up multiplying those two linears. It's creating quadratics. That's what we want to recognize so far when we look at this section about dilating a function by an expression. We're going to go beyond this in the next activity, but that's what we want to recognize. Okay? So in the top right, if you're looking at that top right, it talks about if a polynomial has positive or negative. How do we know if the polynomial has positive or negative values? What did we do here? Right here, why are these values of the polynomial negative?
Because they're below the x-axis.
Yeah, but like, why were they below the x-axis, right? When I graphed it,
Because they were the y.
Because the outputs are negative.
but why do we? Which outputs are negative?
The y.
What? It's only what? That didn't make no sense.
Okay.
You just said what output is negative. I thought it was only one output. What you mean?
It's two outputs.
So I want you to look at this
Negative
graph.
output and that's positive.
Hey, Bakari, chill. Right here. I want you to look at this graph. Do you still think that my outputs would be negative in this region?
Yeah, probably.
Say that again, bro.
Do you think the outputs would be negative in this region? Guys, this is the whole point of the bell ringer.
No, it wouldn't.
Why not?
Because it's not under the X. Cause
What's not?
That is
Lord have mercy.
Oh my lord. I'm about to cut my head off.
Guys, Pause. So two negatives make a positive, right? I agree with you there, but where are you seeing negatives?
Nowhere. Wait, what?
But remember, we said dilating a function means what? Multiplying the...
Output.
None of you have talked about our outputs yet. We haven't even...
Nah.
What we haven't done the first thing. Guys, what was the very first thing we always identified? What do we know? What points do we know h of x has to have? It has to have a negative 3, 0. What else does h of x have to have?
0, 0.
0, 0. Guys, start at the beginning. If a polynomial has positive or negative values, what do you need to identify first? You've got to identify the what?
The value.
Say it again. Because remember, guys, what's in between positive and negative?
0.
0, right? So if we want to determine if a polynomial has positive or negative values, ID the zeros first. Whether you're doing that graphically or algebraically, you got to find your zeros. That's the starting point. We know that positives and negatives can only change at zeros. So remember, I mark these x values, right? I draw that vertical line in because now I know which regions to look at. I'm going to look here to the left, I'm going to look in between, and I'm going to look here to the right. Mark your zeros, mark your x-intercepts. Now without using the calculator to graph h of x, would this to the left have positive or negative values? Why? But that's only one line. When I talk about h of x here, I'm talking about taking f of x and multiplying it by g of x. All you did was look at g of x. I will say this. What type of values does g of x have? What type of values right here does g of x have? Negatives, right? But what about f of x? Have you considered that yet?
No.
So f of x, when I look to the left, notice I'm only looking to the left of that 0. These values are positive. Okay?
Wait, how?
What's a what?
Oh.
So remember, if I look, this is above the x-axis. If I look to the right, aren't these positive y values?
No.
So it's all about the outputs. What's a positive times a negative?
Negative.
So to the left of this x-intercept, I have negative values. Right? A positive times a negative is negative. That's it. A positive times a negative is negative. Now, I'm looking in between my zeros. Right? When I look in between those zeros,
Yes.
what type of values are these?
Positive.
What type of values are these?
Negative. Wait,
Remember,
I can
hey guys, when I say values,
Your body can
when I say values, I'm talking about the outputs. These outputs, the y's, are what? They're all positive. What do I get when I take a positive and I multiply it by a positive?
get a positive.
So in between here, all these values are positive. So y'all are right on noticing above and below the x-axis, but my question is not looking at h of x. My question is, how could I have used these factors to know what h of x looks like?
Yes.
And that's what we're doing, right? We're multiplying positives and negatives. So to the right over here, these values are what?
Positive.
Okay? These values are,
Negative.
and what is a positive times a negative?
Negative.
Now, I'm going to hit graph, and let's see if our sketch is correct. So, negative values here, positive values here, negative values here. Was it good? Yeah. It has the right zeros, it has the right positives and negatives. It's good to go. Notice, does it have to be a perfect graph? No, it just has to have the right sketch. So, what do we need to do? ID the zeros first. What was the next step in determining if the polynomial has positive or negative values? So ID the zeros first, then what?
You said what?
So find the negatives or positive of the what? Which? Remember, these are the roots. By the way, I want you to remember, a root has an output of what? 0.
Yes.
Now this output is 3, but what is 3 times 0?
3 times 0 is 0.
That's why this 0 is still a 0.
Anytime 0 is 0.
Okay? Anything times 0 is 0. What is that called, by the way?
You said what happened?
Zero product property, right? Anything times 0 is 0.
Miss Kenny, what slide is that?
Hey, I just need us to engage right here. Slide 11, but right here. Listen, we identified the zeros, but how did we determine that h of x was going to be positive in this region? What can I call this linear, there's an F word in there. It is a linear function, but when I look at the fact that I am taking h of x, and that's f of x times g of x, what is something I can call the things being multiplied? Say it again.
Factors.
Factors. Guys, we got to know these terms. We got to know the vocabulary. Okay?
You write down.
So, ID the zeros first. Determine the positive or negative of the what? Of the factors. Okay, when we come back from lunch, we're going to have to finish this up. But guys, you got to be able to determine positives and negatives of those factors. This was that stuff like this right here, that h of x is going to share the same what? X-intercepts as f of x and g of x, right? f3 of x and f4 of x. That's one of the big things we talked about in the Desmos activity yesterday. What I'm literally doing is I'm starting with which function? Which function am I starting with?
1/2 x plus 3.
1/2 x plus 3. That's what I'm starting with. And then I'm dilating, which by the way, what does dilate mean that most of us remember? Multiply, right? F of x times g of x. Yes, I'm changing it, but it's not just changing it, right? When we say dilate, the idea of dilation is multiply. When we look over here at the Kings, I think Taj literally wrote it out as 1/2 x plus 3 times negative x plus 2. Or whoever his group was. Sorry, J Mike, sorry. Okay, Taj was the only one who came up and talked to me about it. So J Mike wrote it out as multiplying. But what I also want us to think about is graphing it. And so when we graph it, this group made the note that h of x is going to share the same x-intercepts. When I look at what Maddie drew back there at the aces, notice she drew a parabola. What have we seen so far when we multiply two linears?
They all have the same x-intercept.
So they do have the same x-intercepts, but
Yes.
it also makes a
Polynomial. I mean,
what type of polynomial?
Parabola.
A parabola, right? So please remember, when we multiply those two linears, it created a polynomial. Now, here's what I need us to pay attention to at this point, though. So Maddie drew it as a concave up parabola. Concave up like a cup. But let's look at this again here. All right, we know it's going to share these x-intercepts. Remember in the Desmos activity, how we looked at the vertical lines here? So we marked those x-intercepts with these vertical lines. So I marked my x-intercepts. And I'm going to look to the left over here. This group right here made the note of outputs. And what do they do with the outputs? They multiply them, right? We have this idea that h of x is equal to f of x times g of x. So what am I doing when I dilate?
Multiplying.
Multiply what?
4 and 2.
Multiply the outputs.
Multiply the outputs.
Yes.
Remember, it's 3, right?
So, yes, it is supposed to be 3. I'm going to fix that. That was my fault. Okay? So, I want you to think about that. If this output is 2, and this output is 3, what's 2 times 3?
6.
So, this parabola, this dilated function, should have a y-intercept of 6, right? The x is not changing, but 2 times 3 is 6.
Yes.
So I want you to think about this. Maddie, what you drew was a concave up parabola, and that concave up parabola, would it have a positive or negative y-intercept?
Positive.
That graph over there?
Positive.
Preston, look at the graph. Do you see how
I
the
can't see
y-intercept is below the x-axis? Yes, Maddie.
Let's say negative.
It's negative.
Negative. That's negative.
Look, hold up. Here's what I need you all to pay attention to. Listen. The concavity, that A would be positive right here, right? It's concave up, so A is positive, but what I just asked about was the y-intercept. Would that y-intercept be positive or negative? That's a negative y-intercept.
Yes.
But what we just found over here was that if I take this y-intercept, this output of 2, and I multiply it by this output of 3, I get 6.
6, yes.
It was supposed to be a positive y-intercept. So remember, I need y'all to hear me on this. We're used to quadratic, so we're used to just thinking about concave up and concave down. But what we're about to move into is even stuff like this. This is known as a cubic function. Is that just concave up or just concave down?
No.
Both.
It has both concavities. So we cannot just think about concavity. We have to think about the
Concave output.
outputs and multiplying the outputs. So what I would remind you of is I want you to think about these values right here. These outputs. Are these positive or negative? Why are they positive?
Could they go up?
They're,
They're in the positive section. They're in the positive section.
how do we know they're in the positive section?
Because I'm the.
How do we know these positives are, or these outputs are positive? There we go. Listen, you said the positive section.
That's what I said.
They're above the x-axis. Remember, these y values are quite literally what? Positive numbers, right?
Let's do it.
So these outputs are positive. When I look right here, these outputs, what are they?
Negative.
Positive.
What
Negative.
what
It
outputs?
has a negative slope, but what are the outputs?
Positive.
1,
Positive 2, positive 3, positive 4.
All these outputs are what?
Positive.
And guys, what do I get when I take a positive and multiply it by a positive?
A positive.
Hey guys, what type of number was this y-intercept?
Positive.
6.
So, in between my x-intercepts, all of my y values are positive. Notice, between those x-intercepts, all those y values are positive. Now, I'm going to look to the right over here. And I'm going to look at my outputs. These outputs, are they positive or negative?
Positive.
What about these?
Negative.
And what do I get when I do a positive times a negative?
Negative.
Positive times negative, negative.
So, she's on her way.
Y'all heard
It
that?
went from positives here to the, because I'll point this out. What number is in between positives? Hey, Dewan, you get back there? Tosh?
I don't know what just happened, bro.
Hey guys, what number is between positives and negatives? The number 0, right? And what's this x-intercept also called?
0.
That's a 0, right?
Zero,
So
right.
remember, it's all about those zeros and the positives and negatives. You don't have to make it harder than that. I don't have to literally get that 0, 6, because remember, I'm not expecting super accurate graphs. You can do it. So for example, right here, what is this output?
The output is 2.
What is this output?
4.
4.
And so 2 times 4 is
8.
times?
2 times 4 is 6.
2 times 4 is
8.
okay? So I
That's
can
it.
do individual points like that, but I don't need individual points. I just need positives and negatives. So all of these for my dilated function are going to be negative. When I look over here, do not forget that this continues. So these values, positive or negative? Positive. What about these values?
Negative.
And what do I get when I take a positive and I multiply it by a
Negative.
negative? So after this 0, all these values are
Negative.
So, we're focusing on positive and negatives and multiplying those because quite literally, it's f of x times g of x. It's the outputs of one function times the outputs of the other function. So, positive times negative is negative. Positive times positive is positive. And then past this 0, right, you get back into the negatives.
What is going on?
Just don't forget, at some point it goes into the positives, but at some point it's got to turn around. Why does it have to turn around and start decreasing?
Because
So notice it's increasing all the way
the
through
input
here.
matches the same output. Maybe.
Not just that. Guys, it goes into the positives
So
and then
it's
it's got
one.
to turn around. Why does it have to turn around?
Because it hits the climax.
Not just because of the concavity.
The climax.
Not
That was Press was saying, because it's climax.
Did he say comment?
That was he said. That was what Press said.
Guys, I need y'all to look here again. Hey, excuse me. We're high schoolers. Preston.
Wait, is it
I know
is it
you
because
think
the
you're
rise
being
of
funny.
one?
Dude, what? Ain't that what it's
I
called?
wasn't
The
trying to
climax
teach
is the
you
stop
to be
part.
funny.
Wait, is it the rise of one?
No.
You talking about
That's what the top part is.
The median and.
Hey, pause.
We don't know, really.
No, you do know. Right here. It's increasing. Remember, it started in the negatives.
Right.
And it had to get to the positives. It had to go through this what? Zero. The x-intercept also called a zero. And so it continues to increase in my positives, but it's got to turn around because what does it have to get to? It's got to get back to zero. Guys, it's in the positives, and it's got to get to zero, so what does it got to do? It's got to turn around. It's got to go back down. And so then it gets to the zero here. So what is this all about? It's all about the zeros. And then around zero, you have positives and you have negatives. Yes, Taj?
We're doing this. We're going to be working the platform.
So yes, that's a great question. So you'll notice what Taj is talking about is,
What are you talking about?
yo, Bakari, I'm talking, bro. Okay.
Exactly. Why are you talking to me?
Excuse me, ma'am.
No, like that's actually the mark.
Guys, stop using my markers except for the vertical surfaces. I'm about to rage. I'm tired of seeing expos that have been smashed in because people just jammed them on things. I'm tired of seeing cards that are defaced because we're not paying attention. And don't you dare use my purple like that. Alright, so look, guys, it's all about my zeros, okay? Listen, it's all about those zeros. We gotta pay attention to the positives and negatives around those zeros. Oh, that's what Taj was asking this. You said it's gonna be a lot about which form? Factored form, because remember, this is one of my factors, right? I graphed this one factor. I graphed this factor, right?
Yeah.
This is factored form. And so when we have those factors graphed, then I can figure out my positives and my negatives. So yes, Taj, we're going to start almost exclusively in factored form. But we also know how to get standard form from that. So I will say that again. The area model, right? So one thing we're going to get into either today or tomorrow is we are then going to take, wow, that was ugly. I'm going to take my area model and go to my standard form, right? So great look at that. Great question on that, Taj. So that don't forget, Taj, if you want, you can come up here and grab a piece of candy out of the Bluebell ice cream box. I literally just brought it today, Maddie.
I asked a question 30 minutes ago, and I ain't getting no piece of cake.
It wasn't a good question.
Miss Kenny.
That's cool.
Miss Kenny.
Let me ask a question.
Miss Kenny.
I need better
We got a
questions.
lot of candy too.
Yeah, we got all left over from Halloween.
Oh, what y'all say?
Who?
Alright.
I got a question to ask. Give me some
Kenny.
questions.
They can have my back. I was using it for the burger first. Can I get back?
Huh?
The marker out.
Not the purple?
I was using it for burger first.
Dog, who's the only person in this room that writes in purple?
Well, yeah, no.
Queen.
Bakari.
There is that mark right there.
All year. Listen. Focusing. Task. We're going to continue working with that dilations, that Desmos activity. We're going to get into part 2, which is all about cubic functions. And so one, I want to point this out concepts-wise. We've studied quadratics. Like, how have we always talked about a quadratic in the past? Like, what was a quadratic function?
Parabolas?
It was parabolas. What else have we talked about with quadratics?
Linear.
Well, linear what? Linear, not a linear function, it's a quadratic function. Linear
Linear additive rate of change.
Linear additive rates of change, right? That's how we've seen our quadratics. No, it's not a question, dog.
I asked you 2 questions though.
You gotta
Asking questions, thinking ahead, right? You don't just get a candy. I'm not giving out candy all the time. I want better thinking. So I'm rewarding phenomenal thinking. Okay, so
I'm phenomenal. Think about me.
what?
I'm phenomenal. Very
I have a question.
Okay, so what I'm trying to get us to notice now, hey, what I'm trying to get us to recognize now is what's another way to understand quadratics? Well, it's the product of what?
Zero.
Okay.
Wowzers.
Guys, what's right here that we use to get my quadratics? It is outputs of what? Of how many linear functions? Two, right? A quadratic is the idea of a dilation or a multiplication of two linear functions. That's what's going to extend us into this idea of what a cubic function is and how we can use factors of a polynomial to determine the graph. At the end of today, I'm going to come back to this proficiency scale because we should have a lot of these ideas already mastered. The foundation is something that I made sure was based on things we've done in this class, so hopefully we can do this. But we're going to move into this.
The functions of the
What are you doing?
I just started chipping.
No, sitting on my counter like that.
Oh, I thought.
This
That's a good question too.
So,
Not that.
all right, really quickly, what I'm going to do is I'm going to make sure we wrap up this Desmos activity. So, I'm going to point this out really quickly, okay? So I'm going to do, this is slide 11 on the Desmos activity. Taj, put it off before I veto your ability to get candy ever again and stop messing with people. Okay, look. So what have we noticed? What did we wrap up yesterday with noticing? How are we getting our dilated function? Oh, we didn't finalize this. We did finalize that, but I did not give you the prayer models.
Get off.
Well, no, we were behind.
That's a lot right there. Got a whole bag full of it.
These are the giant tree.
You said these, so that means it's more.
Hey guys, I need you to go to your group so that we can finalize some notes. No, Chelsea, it's all yours. The entire unit. Good.
I said, get the hell, nigga.